Okay, for this video, we're going to introduce how to multiply real numbers. There are notes in a PDF format, so go ahead and print them out if you'd like to. First thing we're going to talk about is what do you do when you multiply numbers with the same sign? So the sign of the product is numbers that are multiplied together with the same sign always produce a positive value. So if we have something like 5 times 6, that's going to give us a positive 30. If I have 7 times 2, that's going to give us a positive 14, same signs. If we change the signs, negative 5 times negative 6, like this, to negative and negative, but they're both the same sign, we'll still end up with a positive 30, as we would over here. Negative 7 times negative 2 would give us a positive 14. The only time you end up with a different a negative number is when the signs are different. Okay, so if we have a 5 times 6, and that 6 is negative, we'll end up with a negative 30. Notice that the 30 didn't change from this problem up here. The only thing that changed was we now have a negative number instead of a positive number. The same thing would happen over here. Let's say I have a negative 7 times 2. I still get a 7 times 2, which is 14, but I now have a negative because the signs are different. We're going to go ahead and multiply real numbers. We got a negative 3 times 6. Signs are different, so it's going to give us a negative answer, and that should be 18. Negative 18. Over here, we're going to multiply left to right, so we're going to multiply the 2 and the negative 5. Those signs are different, so it's going to give us a negative, but 2 times 5 is still going to be 10, so it's negative 10, and I'm going to multiply that by the negative 4 now. And now I have a negative times a negative, which is the same sign, and that rule says it will be a positive, but 4 times 10 is going to be 40, so we end up with a positive 40 for that answer. Same thing down here, we're going to have a negative half times a negative 4. The signs are the same, or negative times a negative will give you a positive. Half times 4 is going to be 2. And I still have a times negative 3. And at 2 times negative 3, the signs are different. The answer's got to be a negative. And 2 times 3 is not going to change. That's still a 6, so it's negative 6. There is a pattern here. You'll notice that an odd number of negatives here produces a negative number, and that an even amount of negatives when multiplied produced a positive number. That pattern's always going to exist, but that only exists while you're multiplying. If you throw in a plus or a minus in between them, it only exists on the multiplication part of it in the problem. Here are the properties for multiplication. The first one's called commutative properties, just like addition, which means the order in which we write the problem does not change the outcome, in this case a product. So A times B equals B times A, and we can see that these answers here are going to be identical. This is negative 20, that's negative 20. The next one is called the associative property. Addition has an associative property also, so that just means I can group them in any order we want. Normally we go left to right, as PEMDAS tells us to do. So we can say that we can do A times B first, then come and multiply by C. Or I can regroup B times C and then come back and multiply by A. That's called the associative property. So over here, same answer. We'll get negative 14 and then times 4. Or over here, I can get 28 and then times negative 2, and I'll still get the same answer on both sides. The associative property. Identity property. A times 1 equals 1 times A, which equals A. So A times 1, or 1 times anything, will give you the original number back again, or itself, its identity. So negative 5 times 1 does not change the number. You still have negative 5. This one's called the zero product rule, or this one's actually referred to as the property of 0. This simply says that a number times 0 will give you a value of 0. It seems quite obvious, yes, negative 3 times 0 equals 0, but this particular rule, I think I've said this before, comes into play when we start to solve quadratics. This property is what allows us to solve quadratic equations. The property of negative 1, sometimes we end up with a negative variable, and how do we handle it? Well, we'll just go through and multiply by negative 1. So this is the property that allows us to do that. It says that -1 times a number will give you the opposite of that number. So a times -1 will give me -a, and -a, another way of saying that is just opposite of a. So 2 times -1 will give you the opposite of -2, which is +2. And of course, the property of multiplication with same sign still supported here. Negative times negative or same sign gives you a positive answer. Identify the property of multiplication. If you want, you can go ahead and pause the video for a moment, take a look at these, and then try and match them up with these down here. Okay, the first thing I'm going to do is notice that there's a times 0 here. That's the 0 property rule. So I'm going to look through here and see if I can find that. And there it is right there, multiplicative property of 0. Sometimes referred to as the 0 product rule. The next thing I notice is a times 1. So anything times 1 equals itself. In other words, it's its own identity. So I'm looking for the identity property. There it is right there. That's the identity property. Oh, this is a -1. So I'm looking for the property of -1, the multiplication property of -1. There's that one. Let's see, this one right here, letter C, I noticed that the numbers have changed their order. They physically commuted from one place to another. So I'm looking for the commutative property. And that's of multiplication. And the last one by default would have to be associative. And notice that the order of the numbers is the same. We just group them differently. And normally we do the order of operations left to right. However, this associative property does allow us to take multiplication and addition and kind of do it in a different order. We don't always have to do it left to right if it's multiply or addition. You still have to do multiplication before addition, but you don't have to do left to right all the time like that. Use properties of multiplication. You want to find the product of this, but justify our answer. So right now it's just -4x in parentheses times 0.25. So the first thing I would do is bring my 0.25 out in front, and if I physically pick that up, move that out in front, 0.25, and that's going to be a times -4x. When I physically move that, that's the commutative property. So the commutative property of multiplication allows me to do that. Then I'm just going to regroup. Instead of doing the -4 times the x, I'm going to group the 0.25 and the -4. So negative, or 0.25 times -4, and then the x will be on the outside. And if I'm regrouping, changing the order, that's just the associative property of multiplication. Then we're going to go ahead and multiply these two together. 0.25 times -4 will give us a -1, and I've got times x. This particular step is just simply called multiplication. Simple multiplication. From here to here, we just simply multiply those together. And now, we're going to go back to this. Here we have -1 times x, and that will give us -x. And that's what all these will equal each way down. And the reason for that one is that's the -1 property of -1 rule. Okay, so multiplication property of, let's go ahead and call it multiplication property of -1. So anything times -1 will always equal the opposite of that number. Here's an example where we have some changes. In 1900, the elevation of Mono Lake in California was about 6416 feet. That's above sea level. From 1900 to 1950, the average rate of change, so it's changing, was about -0.12 feet per year. That's a rate, feet per year. Feet compared to year, that's what makes it a rate. From 1950 to 2000, the rate of change was about -0.526. So we can see we have two rates of change, one that occurred during the first 50 years and one that occurred in the last 50 years. And the rates are not the same. They want us to approximate the elevation of our, lake? Our lake in the year 2000. This is kind of simple. We do have to identify a few things here. Here's our starting value. We do have a rate of change from 1950 to 1900 to 1950. And we have another rate of change from 1950 to 2000, which is different. And we want to know what our final elevation was over here. So we can set up a little equation here. So we call our final elevation is going to equal our starting elevation plus our rate of change, we'll call it ROC, plus our rate of change times the number of years in which it's changing. And now all we got to do is go ahead and substitute some numbers in there. Our final elevation, which we can't put in there yet, but we do have let's go ahead and put it out. We do have a starting elevation of 6416, and the first rate of change first 50 years was a negative 0.12, and that was occurring for 50 years, so times by 50, and I'm just going to use a little 4-function calculator. You don't need much. So I'm going to do my multiplication first, and we've got a 0.12 negative times 50 years, and that gives us a change of negative 6 feet. Okay? So our change after the first 50 years, we're just going to take 6416 and add a negative 6 to it, brings us to 6,410. So this is our new starting amount in 1950. Now I have to go for the next 50 years, so I have to kind of repeat this again. The difference being is I have a new rate of change. So it's negative 0.526, and that's going to be for the duration of 50 years also. It was changing slower over the first 50 years of the first half of the century than it was over the second half of the century. In fact, it's more than twice as quick of a change in the second half. So we're going to use our calculator here. Negative 0.526 times 50 years gives us a change of negative 26.3 feet. Bring down our 6410, which was our new starting value. And now our final value is actually going to be the sum of these two. So now we're going to add our 6410 to that, and we get approximately, and I'm actually going to change this here. Instead of an equal sign, I'm going to change it to the approximation symbol. Approximately 6,383.7 feet. If you want, you could probably round it up to 6,384 feet, because it does say what is the approximate elevation in 2000. This may not be the exact elevation.